So the Markov analysis is a probabilistic technique that is used to study how events move from the current state to the future state. So we normally have what we call the current state, and then we go through someone known as transition matrix. Transition matrix, and this now gives us what we call the future state. So if you multiply it there, so that is what we call the Markov process, a probabilistic technique that shows how events move from the current state to the future state, obviously after going through the transition matrix. Now, the transition matrix is what we refer to as agent of change. Is what we refer to as agent of change. And for example, now you are in section 2. You are listening to what I'm teaching, and that will take you now to section 3. So what I'm teaching you is the transition matrix, is the agent of change that will see you move from section 2 all the way to section 3. Now, the next thing is when we talk about the states, we have various types of states that are present here. One, we have what we call the recurrent. We have what we call the recurrent or the open or the transient state. Now, the recurrent or the open or the transient is the state which members can freely join and members can freely exit. It's a state where members can freely join and freely exit. For example, this class is a class you freely join and you can freely exit. Then we have another one that we call the absorbing state. The absorbing state. Now, the absorbing, it is where members freely join. But once you join, you cannot move out. A good example is account paid. When the account has been paid, we cannot go back and say that account has not been made. Another example is marriages. We freely join to marriages, but once you are there, you cannot exit. Then if you separate or divorce, we will keep on remembering you are so-and-so's husband or wife. The other one is called crossed state. Now, a crossed state is a state where no new member can join and no existing member can move out. A good example is gender. For those who are born men, you remain a man. For those who are born ladies, you remain a lady. You cannot change successfully to the other side. Another example is a tribe. Where you are born or even in a family, you cannot change. You may try to change the name, you may try to deny, or they can chase you away, but it remains that you belong to that tribe, you belong to that family. So those are the states that we have when we are dealing with Markov. Now, the other thing that we need to know is what we are calling the transition matrix. Now, this transition matrix is a matrix that contains probabilities. We call them the BIJs. Now, these probabilities, they show us the likelihood of moving from the current state I to a future state J. The current state I to a future state J. And these probabilities are empirical. By empirical, we mean that they have been derived based on results of actual experiments. That's why we are calling them empirical. Then these probabilities can only be used to predict a future period equal to a period over which they were developed. What we mean by that is, if you have taken 1 month to establish the probabilities in the past, then you can only use those probabilities to predict the next 1 month. But you cannot use the results of something 1 month to predict the next 1 year. Neither can you use the results observed the last 2 years to predict the next 2 days. So there must be uniformity of those periods. The other thing that is very, very important is when it comes to the role of these matrices, you will find it will be showing us what we call retentions. It will be showing us what we call retentions, and then it also shows us what we call losses too. So those are the two things that will be contained in a transition matrix rule. That it shows us the retentions and the losses too. And when you add the PIJs there, they must always add to 1. They must always add to 1. Then we have the column here. Now the column shows retentions. It shows retentions, and then it also shows gains from. It shows gains from. So when you're dealing with the transition matrix, the column will be showing you what has been retained and what has been gained, and we will be showing that in our one. Now from there, the next thing that we need to check is about the assumptions. Assumptions are already, some of the things I've already said, that the probabilities are empirical, that we are using uniform periods. Another one that we need to mention is that the states are finite. The states can be counted. You can be able to know how many they are, and they don't keep on changing. Now, the other thing that we finally need to look at is the applications. The applications of Markov analysis. Now, these applications are numerous, as you can see in your notes. One, you can use it in a school if you want to study how pupils or students move from enrollment all the way to graduation. You can study that. You can use it in human resource management when you want to study what we call labor turnover. Labor turnover is the rate at which employees quit from an organization. So we want to know at the beginning of the year, how many people do we have? In the course of the year, how many left, how many came in, how many do we have at the end of the year? That is called labor turnover and is human resource management. The other one is investment analysis. When you are doing investments, it can help you to know the movement of prices. You are able to know towards which direction prices are moving, and you are able to strategically position yourself. The other thing is you can help, you can be assisted by Markov when you are doing adverts. You are able to tell towards which direction are customers moving. And then it also helps you to measure the effectiveness of your adverts so that you're able to know who moves to where based on which adverts. So those are some of the applications that we find even in financial reporting when we are talking about the behavior of the debtors, those who will pay, those who will not pay, the provision for doubtful debts, how many will turn out to be bad debts, all those, they are based on Markov analysis. So that is what we can say as a brief description of Markov analysis. Now I want you to take your past papers, not your past papers, the handout which I gave you, which has questions, so that we can solve those questions. So in question one, which is a question that was tested in June 2003 as question 1A. June 2003, question 1A. It says that in a recent research survey by intelligence consultants, on the use of services of auditing firms by the various NGOs. In the year 2002, the findings were as follows. So we are given all that, and then we are told determine which audit firms are likely to audit more NGOs in 2003 financial year. Now, in order to handle that, we will come here and say, if you take 2001 and multiply by the transition matrix, it is going to give you 2002. It's going to give you 2002. 2002. So, kwa tunapanga namna hii. So, as you can see, we have 4 companies. One is called BM, the other one is called BT, the other one is called BA, and the other one is called EA. That is according to information number 5. And according to information number 5, we are told BM has 0.2, BT has 30%, that is 0.3, BA has 0.4, and EA has 0.1. Now we are supposed to multiply by transition matrix. And this transition matrix is written like this: from PM, BT, BA, and EA to PM, BT, BA, and EA. That is 2. Should be equal to PM here, BT, BA, and EA. You're dealing with Markov. So you get your, I think I gave you the handout on Markov, the matrices. So we are in question now, we are on page 11. So information 1 says, out of those NGOs which used PM auditors in 2001 financial year, 10% switched to DT auditors. So as I have told you earlier, this transition matrix shows us the movement from to. So we are told from PM to DT. So from PM to BT is 0.1. And those who went to BA, 0.1. Those who went to EA, 0.1. Then you remember, I've just told you that these values must add to 1. And they represent, these are losses now. So the value that remains is the retention. So that must be 0.7 so that we are able to add to 1. When we read information 2, we are told out of those which used BT in the year, 20% switched to BA. So we are saying from BT to BA, 0.2. Then from DT to BA or to EA, 0.1. So from DT to EA, 0.1. That is all that we are told about that company. So it therefore means that they did not lose anyone to PM, and they must have retained 0.7 of their customers. They must have retained 0.7. Then when we go to BA, we are told out of those which were using BA, 110% switched. 110% switched. So they switched to EA, so 0.1. So that means BA must have retained 0.9. If they did not lose there, they did not lose. And then, out of those which used EA, 20% switched to PM. So 20% came here. 10% went to DT, 0.1, and 0.1 here. So that means what was retained is 0.6. So that is how he had copy. What are those matrices? You have them? Don't know there. Notes are matrices, hard copies, other than the soft. But I also sent you the soft. So let's multiply. So we start to multiply. As usual, we normally take these ones multiplied by this. So it will be 0.2 times 0.7 plus 0.3 times 0 plus 0.4 times 0 plus 0.1 times 0.2. So the answer is 0.16. And then you do the same here, you multiply by this, so that we say 0.2 times 0.1 plus 0.3 times 0.7 plus 0.4 times 0 plus 0.1 times 0.1, 0.24. 0.2 times 0.1 plus 0.3 times 0.2 plus 0.4 times 0.9 plus 0.1 times 0.1 0.45. 0.2 times 0.1 plus 0.3 times 0.1 plus 0.4 times 0.1 plus 0.1 times 0.6 is 0.15. And as you can see, these ones, they are adding to 1. If you add them, 0.16 plus 0.24 plus 0.45 plus 0.1, they're adding exactly to 1. So copy that quickly as I do the other one here. Now for the 2002, you multiply by transition matrix. Transition matrix. This now should give you 2003. 2003. Someone is correcting me. You're saying EA is 0.16. Let me check again. If it is 0.16, I enter 1. Check again, you're working. So for the PM here, we have DT, we have BA, and we have EA. Now we take those ones that are there, 0.16, 0.24, 0.45, and 0.15. 0.15. So we are saying times. This is the transition matrix from, we have PM, we have DT, we have BA, and we have EA. This is to PM. We have DT, we have BA, and we have EA. This is 2. So this matrix remains the way tulikuwa tumetengeneza. It does not change. Actually, this is also one of the assumptions. It does not change. So we just multiply as usual. So we are taking these ones, we multiply by these ones. So 0.16 times 0.7 plus 0.15 times 0.2. I'm getting here 0.142. Here again, 0.16 times 0.1 plus 0.24 times 0.7 plus 0.15 times 0.1. I'm getting 0.199. 0.16 times 0.1 plus 0.24 times 0.2 plus 0.45 times 0.9 plus 0.15 times 0.1. I'm getting 0.484. And the last one is 0.16 times 0.1 plus 0.24 times 0.1 plus 0.45 times 0.1 plus 0.15 times 0.6. 0.175. And you should always confirm that they are adding back to 1. They should add back to exactly 1. Good. So now, the question was asking us who will audit more. So you compare like this. You see, when we began in the year 2001, PM equal to 20%, but it's now ending with 14. So it has declined. DT it began with 30. It is ending with 19.9. So it has also lost. BA began with 40, now it's ending with 48. So it has gained. And EA began with 10%, now it's at 17. So the advice or the conclusion is that BA and EA will audit more clients in 2003 compared with 2001. So in 2003, we will have more clients. So they are growing. The others are losing the market. So copy that and be fast. Okay. So we move on to the next question. That says the manufacturer of terms of drinks has been facing stiff competition from other, that's on page 12. From other manufacturers is now considering whether to undertake an advertising campaign or not. If the current branding remains the same, the transition matrix is as follows. So we are given that. After the campaign, which will cost 20 million, the transition matrix is expected to be that way. The market size is rather 40 million customers, and profitability per customer is shillings 500. You are required to recommend whether the advertising campaign should be taken in the long run or in the short term. Now, if you look at what we have here on the whiteboard, this current state here is different from the future state here. The same case here. This current here is different from the future. When you get exposed to something for the first time, it changes you. But if the exposure is prolonged, you come to what we call equilibrium point, or what we call the long run. Now, long run means that there will be no change, even after we multiply. That this one, we multiply with this, the answers here will be exactly these ones. That's what we call equilibrium. It is like now that I'm teaching you, maybe I really hope you are understanding, and therefore it is changing you. The way you came in is not the way you are. But if I continue teaching you the whole night and even tomorrow, itafika mahali and your systems will shut down, just broke. And any further talk that I do when you already have shut down, you remain the same. There will be no change. So the way we answer, nimeongea, nimepiga makelele, you are still the same way. So that's called equilibrium. We call it the wrong start, the wrong run. We also call it the steady state. So that is the concept that we are supposed to use in the next question. So that we can advise these guys on the way forward. So it's a question that was tested in June 2005, question 1B. June 2005 as question 1B. Now, in order to answer this, we will say, let long run shares be, let the long run shares be, we can write together, X is representing Tamu, and Y is representing others. X is representing Tamu, and Y is representing others. Where X plus Y is equals to 1. X plus Y is equals to 1. And Y is equals to 1 minus X. Then, before the campaign, before the campaign. Before the campaign, we will have a term here and others. Now, term is represented by X, others are represented by Y, but now instead of writing Y, we will write 1 minus X, because you have said Y is represented by 1 minus X, times the transition matrix. The transition matrix, we have term here and we have others here. Then this is term and this is others. So we have 0.85, 0.25, 0.15, and 0.75. It should give us term here, and term is represented by X. Then we have others who are represented by 1 minus X. And that is what I've told you, that after you multiply, you can see this remains. That's what we call the long run. So you now solve. So on solving, just like what we have done with the others, so you take these ones, you multiply by this. So X to multiply this, we will get 0.85X. Then these two to multiply this, so that we get 0.25 minus 0.25X. Now these ones, they should give us this X here. Should give us that X. So if they are giving us X, we then proceed and say 0.85X minus 0.25X minus 1X is equal to minus 0.25 when you put like terms together. And you put like terms together. So this one now becomes 0.85 minus 0.25 minus 1. I'm getting minus 0.4x being equal to minus 0.25. And based on that, x should be equal to 0.625. And y should be equal to 1 minus 0.625. It should be 375. Thus, we have the farm here. Then for us to get the profit, we will have the market size times market share times profit per customer, profit per consumer, you minus the costs. This will give us the profit. This will give us the profit. So if we start with the TAMU, and remember TAMU was represented by X. The market size is 40 million. There are 40 million customers. And X is 0.625. And the profit per customer is 5. And we have not incurred costs. We have not incurred any costs. So if you take 40 times 0.625 times 5 minus 0, you realize that we have made a profit of 125. And then for the others, and remember the others were presented by Y. The market size is still 40, but now the market share is 0.375. Multiplied by the profit per customer, which is 5. You minus 0. So 40 multiplied by 0.375 multiplied by 5 is 75. So that is what happens before the campaign. Then from there, you tell us after the campaign, what happens? After the campaign, we will change the transition matrix here. The transition matrix, we are told it is 0.9. We have 0.3, 0.1, and 0.7. So I would like you to solve the same way we have solved. The same way we have solved. And then they are doing a campaign that is costing 20 million here, but these ones have not done a campaign. So nataka we solve like we have solved the other one. Kuje, you give me the profits. Yeah. Managed? Those who are online, send your answers. Be fast, be fast. minutes. Okay, so you multiply here, you get 0.9x plus 0.3 minus 0.3x is equals to x. Then you put right terms together, you get 0.9x minus 0.3x minus 1x is equals to minus 0.3. Then when you subtract, you say 0.9 minus 0.3 minus 1 is negative 0.4x being equal to minus 0.3 multiplied by 0.3 is 0.75. So this must be 0.25. That way. And therefore, this one I multiply by 0.75, this I multiply by 0.25. So I'll say 40 times 0.75 minus, times 5 minus 20. That gives us 130. That gives us 130. Alafu 40 times 0.25 times 5 minus 0, it is 50. So the advice is they should do the campaign. Because the profits have increased from 125 to 130. This one. Yeah. So this is the one number. Yeah. So you multiply by this, you put a 0.3 and put a minus 0.3x. Do the campaign. Okay. Now look at the next question that follows that. So if you have read the question, want us to do the transition matrix. And from this side, we have Jana, and here we have Leo, and here we have Kesho. Then here, obviously, we shall have Jana, and here we have Leo, and here we shall have Kesho. 2. And this is how it's done. If you look at the column that is written 2006, you can see Jana had 204. But it lost 15 to Leo. So from Jana to Leo, we lost 15 out of the 204. And then we lost 9 out of the 204 to Kesho. So the argument goes like this. If we had begun 204, we lost 15, and we lost 9. We must have retained what? 180 out of 204. Now this 180 divided by 204, you will get 0.882. 15 divided by 204, you will get 0.074. 3 decimals. And 9 divided by 204 is going to be 0.004. And anytime you do that, you must always confirm whether they are adding to 1. So 0.88 44. So you add 0.074 plus 0.044. They are adding exactly to 1. That's good. We argue the same for Leo. Leo, you can see it lost 12 to Jana against 416. They began with 416. Then it lost 7 to Kesho, and they began with 416. So if you divide, or rather you want to subtract 416 minus 12 that was lost, minus 7, you get that they retained 397 out of 416. So we start 12 divided by 416, 0.029. 397 divided by 416, 0.954. 7 divided by 416 is 0.017. Now check whether they are adding to 1. 0.029 plus 0.954 plus 0.017. So they are also adding to 1. We argue the same way here. This is 20 against 5 that 1. So we can even divide 20 divided by 5 that 1 is 0.038. We lost 5 against 5 that 1. So 5 divided by 5 that 1 is 0.009. Then how many did we retain? 5.1 minus 20 minus 5. We must have retained 506 against 5.1. So divide by 5.1 and get 0.953. So 0.038 plus 0.009 plus 0.953 equals exactly 1. Now, in the event that they don't add to 1, you subtract the first 2 from 1 so that you get that one, because they must always add to 1. So that is how you can make the transition matrix when you are given those figures. And as I told you, the rows are the ones that are showing us the losses. But you can also work with columns which are showing the gains. You can see these are the gains. You can see these 12, these 20. You can see them, eh? Yeah. So that is how you make the transition matrix. Then we are told to get the market share and the clients for each firm as that 1st of December. So that should be 2017, or that should be 2008, not 2017. So that we argue that 1st of December 2007, when you multiply by transition matrix, you should get that 1st of December 2008. So if you want to convert this for Jana, what you do first, you add the clients who are there in 2007. So 212 plus 417 plus 522. It's a total of 1151. So if you take 212, you divide by 1151. Is 0.184. Then you come and do the same thing for Leo, which is 417. You divide by 1151. So 417 divided by 1151. 0.362. And then when you come to Kesho, it is 522. You divide by 1151. 1152, that is, no, 51. 1151. You have 0.454. And you must always check whether they are adding to 1. So 0.184 plus 0.362 plus 0.454. See, they are not adding to 1. Now, if they are not adding to 1, this one now must be obtained like this. You take 1, you minus here kwanza, 0.184 minus 0.362. Actually, that is the way we normally use. But once you get these two, you subtract them from 1, so that you just go straight and with visuality. So you come now and multiply with the transition matrix. This transition matrix, we can just copy the way it is: 0.882, 0.029, 0.038, then here 0.074, 0.954, 0.009, 0.044, 0.017, and 0.953. So I want you to multiply and give me the answers. So multiply these ratios, the way to multiply, copy and multiply, give me the answers. So you should have 0.184 times 0.882 plus 0.362 times 0.029 plus 0.454 times 0.038. If I am working with okay. That's the answer I'm getting. 0.184 times 0.074 plus 0.362 times 0.954 plus 0.454 times 0.009. This is 0.36305. And as I've told you, the third one, you just subtract it. You just say 1 minus 0.190038 minus the answer, so that we get 0.446912. So those are the shares. This is for Jana. This is for Leo. And this is for Kesho. And if you want to know the clients, for Jana, you take 0.190038 times 1151. For Leo, you take 0.36305 times 1151. And for Kesho, you take 0.446912 times 1151. Okay. Okay. So now from there, we are told to do the long run. This is what you do, just like we did with the other one. You come here and say, let the long run shares B, the long run shares B, X isimamie Jana, Y to represent Leo, and Z to represent Kesho, where X plus Y plus Z is equals to 1, and Z is equals to 1 minus X minus Y. Now, the reason as why we do this is to minimize the work to be done, so that we, instead of dealing with 3 equations, we just deal with 2. Love that point? Okay, then we are going to have X, Y, then 1 minus X minus Y. You multiply by the transition matrix, 0.882, 0.029, 0.038, 0.074, 0.954, 0.009, 0.44, 0.017, 0.953 should be equal to x, y, 1 minus x minus y. So that is the long run state. So we just multiply these ones with this. So the same 0.882x plus 0.029y plus sasa hii yote ina multiply na hii. So that you tell us 0.038 minus 0.038x minus 0.038y should give us x. We put right terms together. This one for x, we have 0.882x minus 0.038x minus 1x plus 0.029y minus 0.038y is equals to minus 0.038. Then if you take your calc, you'll be able to establish that 0.882 minus 0.038 minus 1. This is minus 0.156x. 0.029 minus 0.038. So this is minus 0.009y is equals to minus 0.038. And that is equation number 1. Now, because we have two unknowns, we must get two equations. So tuchukue hii multiplied by this so that we are able to solve. Ile ya kwanza ilikuwa na x, we just multiplied with the first one because we had just one unknown, therefore we only required one equation. Sasa hii we require two. So to get the second one, it will be 0.074x plus 0.954y plus 0.009 minus 0.09x minus 0.009y is equals to y. Then this becomes 0.074x minus 0.009x plus 0.94y minus 0.009y minus 1y should be equal to minus 0.009. And when you put the figures in the calc, you will be able to say 0.074 minus 0.009 I'm getting 0.065x minus 0.954 minus 0.009 minus 1 is 0.05 is minus 0.009, and this one you call it equation number 2. So that is how you create the two equations so that you can solve them. Now, these equations, because they are simultaneous, you can solve them using whichever method. We have various methods of solving simultaneous equations. But because we are in the topic of matrices, I wanted to solve using matrices. So using matrix algebra, method to solve, we are using matrix algebra. I told you we created the matrix using the coefficients. So this one, I'm going to have minus 0.156 and 0.009, which is also negative. Then this is 0.065, and this is minus 0.055 EV. To come to multiply x here and y here should be equal to minus 0.038 minus 0.009. Sasa nataka you solve. Tumekuwa tukisoma how to solve equations using matrices. So solve this and give me the answers. What are the answers? So this becomes x, y is equals to minus 0.156, 0.065, minus 0.009, minus 0.055. Inverse comes in as inverse to multiply minus 0.038 minus 0.009. I told you you get the determinant. The determinant to be minus 0.156 times minus 0.055 minus 0.065 times minus 0.009. So minus 0.156 times minus 0.055 minus 0.065 times minus 0.009 is equal to 0.009165. So xy should be equal to 1 out of 0.009165. The new matrix, tukasema you change the position so that you have minus 0.055 and minus 0.156. Here you change the sign, so we have minus 0.065 and this is 0.009. You multiply by negative 0.038, halafu negative 0.009. So you just multiply. So minus 0.055 times negative 0.038 plus 0.009 multiplied by minus 0.009 equals, then you divide by 0.009165 and you register 0.2192. Alafu huyu mwingine useme minus 0.065 multiplied by minus 0.038 plus minus 0.156 times minus 0.009 equals, divide by 0.009165 is 0.4227. Yeah, good. I can see those answers. All right, good. So thus, x is 0.2192, y is 0.4227, and z tulikuwa tumesema ni 1 minus x minus y. So this is 1 minus 0.2192 minus 0.4227 is 0.3581. So those are the long run shares. So You can try those ones together with any other that is in the past papers. So I'm going to send you another video. I think I've solved, I don't know whether they are same questions or different ones. On Markov, so that you can watch and get a better understanding. So we then call it at that point, then we pick up from there the next lesson. Look at the last one.